Hello everyone, my name is Michael Crow and this is my presentation Beyond Zero Emissions, Assessing the Environmental Impact of Electric Vehicles. So starting off, my presentation and my final project was based on electric vehicles being promoted as a climate solution. Um, Obviously, many people don't know this, but the United States actually lags far behind most other countries in global adoption of electric vehicles. For comparison, they're only at about 10% of new vehicles being sold, while leaders like Norway are at 92% and Sweden are at 58% market share. And the zero emissions label on these vehicles can be misleading because they're not even entirely zero emission during use because of the region they're in and where they generate their electricity from, as we'll later get into. And the goal of my report was to assess the full life cycle of electric vehicles to see when they have their biggest impact. So my methodology for this paper was focusing on the manufacturing, use phase, and end of life, and sort of dissecting each section to see where electric vehicles do the worst and where they do the best in their emission savings. I use sources that are pretty recent from 2010 to 2024, and I look for key terms like EV life cycle emissions, and battery manufacturing. So moving into the manufacturing emissions of these vehicles, battery production actually accounts for 30 to 60% of the emissions from these electrical vehicles being made. Um, Electricity source of where it's being made does affect the emission levels. For example, China relies heavily on fossil fuels, so it's going to be a lot less effective than places like Sweden, which utilize a lot of renewable energy sources. Some companies have begun to address this by, for example, Tesla is using vertical integration and plans to source their own lithium from clay in Nevada to lower their carbon footprint, which will make it a much more sustainable mining process. All right, there we go. Moving to the use phase when you're actually driving the car and stuff, it really depends on the grid of the area you're in. The phrase tailpipe zero emissions doesn't necessarily equal total of zero emissions, as mostly depends on regional electricity source. For example, California has a lot of strong savings for electric vehicles because they use a lot of renewable sources, and meanwhile, the Midwest relies on a lot of coal to generate electricity, so there's not going to be much savings there. And hybrid vehicles can actually be more efficient than them. As we move to one of the graphs I've made for my paper, the life cycle emissions comparison, we can see how a dirty grid for these clean vehicles can actually be much worse than hybrid electric vehicles, because you need to pair electric vehicles with clean energy to actually be the most effective. Here's a really big topic that isn't often discussed with electric vehicles, and it's the end of life kind of cycle for these batteries. Um, Recycling infrastructure is really underdeveloped, but there is promising closed loop recycling, which can reduce emissions from this process by 17 to 30%. The EU has begun to develop sort of or promote this by tracing the origin and recycling status of electric vehicles to ensure ethical sourcing. And you can see how this can be a really big issue considering the size of the battery in that picture, which is on the Porsche Taycan and weighs around 1,300 pounds. So to wrap things up, overall electric vehicles are in fact cleaner, but not entirely emissions free, and they must be paired with clean energy and ethical supply chains to be effective. We should really start supporting battery recycling and long-lived electric vehicles, and we could do so through recycling and battery innovation. Overall, I think my perspective on the topic really shifted from more of a skeptical side to informed optimism, as we can start to move forward with these renewable energy sources. We'll see bigger gains from these vehicles. Thank you.